Hi, in this short video recording, we shall discuss about correlation and regression analysis. So, correlation is a statistical technique to measure the relationship between two variables. However, the regression measures the cause and effect relationship. As it is written here, that correlation finds the relationship between two quantitative variables without being able to infer causal relationship. The correlation only measures that whether these two variables are correlated or not. In economics, for example, we say according to law of demand, when price of a product increases, keeping other things constant, the quantity demanded decreases. So thus we are talking about correlation between price of a product and its quantity demanded. Similarly, this correlation concepts can be applied to many variables in accounting, economics, and finance. For example, we can check the correlation between stock market and currency market. We can check the correlation between employee outcome and its salary. Similarly, we can check correlation between advertising expense and the sale. So correlation is a statistical technique used to determine the degree to which the two variables are related. However, it is not able to capture the causal relationship. By causal relationship means that it does not tell us that out of the two variables, which variable is causing a change in another variable. It only tells us that two variables are correlated with each other or not. Now, if we have two quantitative variables, and one variable is called independent variable and the second is called dependent variable, and we draw the dependent variable on y-axis and the independent variable x-axis, and we then draw all the points. This diagram is known as scatter diagram. It gives us a basic insight into the relationship between y and x variable, that whether they are correlated or they are not correlated. Here we have example. We have weight in kg and we have systolic blood pressure here in the second column. We need to know that whether the weight of a person and its blood pressure are correlated with each other or not. If we look at this basic data, we can have an idea that when the weight is 67, the blood pressure is 120, and when the weight increases to 114, the blood pressure becomes 200. So from the data, it looks like there is a positive correlation between weight of a person and its blood pressure. However, we shall further explore with the help of diagram, which is known as scatter diagram. So we show systolic blood pressure on y-axis in this scatter diagram, and we show the weight on x-axis. This point is the point which indicates that when the weight is 67, the corresponding value is 120 on the y-axis. So in this way, when we draw all these points which connect basically the SBP with the weight, we call this entire diagram a scatter diagram. And as these points indicates that it looks that there is positive relationship, because as the weight on x-axis increases, the blood pressure which has been shown on y-axis also increases. So from this scatter diagram, using these points, we can conclude that overweight people are likely to have higher blood pressure. Now if we draw a line between these points on a scatter diagram, that line is known as basically a regression line which tells us the relationship between systolic blood pressure and weight. From the scatter diagram, we can have an idea that those two variables could be having positively related with each other, could have negative relationship, and may have no relationship with each other. Now, if the relationship is positive, the scatter diagram will look like this. Example is that final grade in a course is on y-axis and number of hours spent studying is on the x-axis. So the theory says that the higher the number of hours spent studying will be, higher will be the grade. Thus these points look like going upward, and it indicates that these two variables have a positive relationship. Now this is again as another example that age on x-axis and height on y-axis, it again looks that there is a positive relationship between these two variables. This is the scatter diagram. So higher will be the age in weeks, the higher will be the height in centimeter. Thus both of these variables are positively correlated with each other. If the relationship between two variables is negative, then the scatter diagram will look like this. Now in previous two diagrams, the points were going upward. Here the points are going downward. Example, as the age of car increases, its reliability decreases, and if the age of car is lower, then the reliability is higher. This is negative relationship. Negative relationship is a relationship in which if one variable increases, the second variable decreases and vice versa. If two variables are not related with each other at all, then scatter diagram like this will appear. Now from these points, it is very difficult to guess any direction of a relationship between weight and pulse rate. Now correlation coefficient. Correlation coefficient is a statistic which shows the degree of relationship between two variables. It is also called Pearson correlation or product moment correlation. It measures the nature and strength between two variables of the quantitative type. If the variables are of qualitative type, then we cannot use the Pearson correlation. By qualitative variable, we mean those variables which cannot be measured quantitatively. For example, gender, marital status. Now these are the variables which are not quantitative. The sign of R, which is used to denote the correlation, it measures the direction of the or nature of the relationship. If it is positive, the variables are positively correlated. If it is negative, we call the variable having negative correlation. However, the value of R denotes the strength of the association between two variables, that how strongly those two variables are correlated. If the sign is positive, this means the relationship is direct. However, if the sign is negative, it means that the relationship is inverse, negative, or indirect. It's same thing, which means that an increase in one variable is associated with a decrease in another variable. The value of the correlation coefficient denoted by R lies between -1 to +1. -1 and +1 both are perfect correlation. -1 is perfect negative correlation, while +1 is perfect positive correlation. Between these two extremes is 0, which shows no correlation. Between 0 and -1, there is indirect or inverse correlation between these two variables, any two variables, and between 0 and +1, it is direct correlation. Again, we can divide the direct as well as indirect into weak, intermediate, and strong. If it is between 0 and 0.25, we will call it weak positive. Between 0.25 to 0.75, intermediate positive. between 0.75 to 1 strong positive. This is not a universal rule. Some people call the relationship strong even if it is bigger than 0.5. The same thing applies on the negative side of the correlation. This has already been discussed in the last slide. Now here we have some exercises. Now we'll see the plot A, plot B, plot C, plot D, and then we shall guess that what type of the correlation will be. Please note that these are the scatter diagram. Now the points on plot A are more close to each other, so we'll call it, and it is going downward, so this is a negative relationship, and we can say that it is minus 0.95. So minus 0.95 belongs to the A part. The second negative correlation in the diagram is D. In D part, it is going downward, so it is negative correlation. So 0.9 belongs to the scatter diagram D. Then in plot B and plot C, both have positive correlation, but if we look at the points in plot B are more close to each other than they are in plot C. So plot B indicates that the variable are more closely related to each other. Thus, we can say that this 0.93 belongs to the plot B and 0.49 belongs to the plot C. So this is apparently what we get or what we infer from the scatter diagram. Now regression analysis. Regression is a technique concerned with predicting some variables by knowing other variables. The limitation of correlation is that it does not tell us that which variable is causing a change in another variable. So which is a dependent variable or which is independent variable, we don't know with the help of correlation. If we want to know the impact of one variable upon another variable, or we want to predict one variable on the basis of another variable, we use the regression analysis. Regression analysis is a process of predicting variable y, which is known as dependent variable, using the variable x. It tells us how values in y change as a function of changes in the value of x. Thus, y is a dependent variable while x is an independent variable in a regression analysis. The difference between correlation and regression is that correlation describes the strength of a linear relationship between the two variables. Linear means a straight line that slope remains constant. However, regression tells us how to draw the straight line described by the correlation. If we run the regression analysis, as I have already shown that this is the regression line, which tells us that systolic blood pressure depends upon the weight. So we always show dependent variable on y-axis and independent variable on x-axis. Now the regression line makes the sum of the squares of the residual smaller than for any other line. So if we draw any other line, the sum of the square of the residual will not be as smaller as we get in case of regression analysis. Residual is the distance between these points from the regression line. So thus we can say that regression minimizes the residual. This is the reason that it is also known as OLS, ordinary least square, which means that the square of the residual is least. Now here we have the basic regression equation in which y is a dependent variable, a indicates intercept, b indicates the slope, and x indicates the independent variable. Now we shall explain what do we mean by intercept and slope. So this is the basic regression equation in which y hat, which is estimated value of y, is equal to a, which indicates the intercept, which is also denoted by beta naught, plus b, which indicates or denotes the slope or coefficient, into x. So x is independent variable. So this is the basic regression equation in which this a is also known as interceptor constant, which is value of dependent variable y when our independent variable x is equal to 0, while b indicates their slope, and slope or coefficient tells us change in a dependent variable due to 1 unit change in independent variable. This intercept and slope together are also known as parameters. Now, in this diagram, we can see the blood pressure shown on the y-axis and weight has been shown on the x-axis, and this regression line crosses these points among them. The regression line describes the regression line it is described by intercept and slope. As I've already told that intercept is the value of dependent variable when independent variable is equal to 0, and slope is change in dependent variable due to 1 unit change in independent variable. Graphically, slope is change in y divided by change in x. So if we move from this point on x-axis to this point on x-axis, on the y-axis we are moving from this point to this point. So change in y divided by change in x is known as slope or coefficient or beta. While if the x is equal to 0, then this is the minimum value of dependent variable, and this is known as intercept or a constant, which has been denoted by a in this equation, but many times it is denoted by beta naught as well. Now this is a second example of a scatter diagram in which the grade of student has been shown on the y-axis, while the number of hours studying has been shown on x-axis. Theoretically, grade depends upon the number of hours studied, and these points indicate that these two variables are having positive correlation, and theoretically grade is y or dependent variable while number of hours is independent variable. If we insert the regression line in this scatter diagram, we get the alpha or intercept, which is also denoted by beta naught, is 59.95 plus slope is 3.17, which is multiplied by study hours. So this is just like y is equal to beta naught plus beta 1 into x, or as I've shown in the previous slide, y is equal to a plus b into x. Now this shows that 59.95, as we discussed, that this is intercept, which is value of dv when iv is equal to 0. So we shall interpret this 59.95 as that if a student does not study at all, his grade in the course will be 59.95%. And if as slope is 3.17, so we shall say that with every 1 hour increase in the study hours spent, the final grade in the course will increase by 3.17%. Now, if we want to predict grade of any student on the basis of the study hour, we can easily do it by multiplying the studied hour with 3.17 and adding it with 59.95. Now, if a student has studied 12 hours, then we can easily find his final grade by putting this 12 as x and using the slope of 3.17 and multiplying the slope with the 12 and then adding it with the intercept. So we will conclude that the final grade of a student who has studied 12 hours will be 97.99%, almost 98%. Similarly, if a student has studied only 1 hour and we have found the regression equation, then we can easily predict the grade of that student who studied 1 hour by putting this 1 hour in x in the regression equation. So this was our regression equation 59.95 plus 3.17 into x. So now x will be 1 hour and the final result will be 63.12. So we shall conclude that if a student studies 1 hour, regression equation predicts that the final grade of that student will be 63.12%. Now this is another example. We have a sample of 6 persons. We have data of their age, which is our independent variable or x variable, also known as explanatory variable, and their weight is demonstrated in the following table. Weight is a dependent variable, so we shall predict the weight on the basis of the age. Now here we have serial number of 6 people, and here we have age of those people. Here we have y any weight of those 6 students or any persons. Now on the basis of this age, we shall estimate the weight, but we can do it only after we estimate the regression equation, or we show it with the help of a scatter diagram. Now let's move to Excel, where we shall draw a scatter diagram of weight and age. Then I shall add the regression line and try to show you the regression equation using the Excel. Let's go to Excel now. Now here we have the data of, let me zoom in a little bit. So here we have the data. Blood pressure is dependent or y variable, while age is independent or x variable. So we are going to first of all make the scatter diagram of these two variables. To draw the scatter diagram, click Insert, go to this chart option, select the scatter diagram here. The scatter diagram has been shown here, but still data has not yet been shown. So we shall select the data here. On this diagram, right click, then click this option select data. Here click add series name. So series name is blood pressure, and series X values are these. Let me zoom in again if I can. Oh, so select this age variable on x-axis, and then it says select y values. So select this blood pressure data on y-axis. Click OK. Click OK. So here we have now the uh, scatter diagram in which we have blood pressure on the y-axis and age on the x-axis. From these points, it looks like that there is positive correlation between these two variables because they are going up. Now click on these points. When all these points are selected, then right click on any of these points, then click here add trend line. Click this option add trend line, and here you can uh, check this option that display equation on the chart. And you see here that this trend line has been added here. This trend line has been added, and this regression line has also been estimated, in which the intercept is minus 0.0417, while the slope Our coefficient is 0.625. This 0.625 indicates that, as we know that it tells us change in dependent variable due to 1 unit change in independent variable. Our independent variable is age and dependent variable is blood pressure. So we shall interpret it that if age increases by 1 year, the blood pressure will increase by 0.625 units. Now let's go back to our PowerPoint slide. This was a scatter diagram in which we just have shown in and made in the Excel, in which weight is dependent variable and age is independent variable. Theoretically, as the age increases, the weight increases. That is why this regression line was going upward, and we found the sign of slope positive. Uh, this is another exercise. Now you should copy this data from this video recording of age and blood pressure, where blood pressure is y variable and age is x variable or independent variable. Try to calculate their correlations and regression and then interpret it. So for example, find the correlation between age and blood pressure is the first question. Then the regression equation is the second question, and then you have to answer that what is the predicted blood pressure for a man aging 25 years. So on this example or on the previous data, you have to do it. However, with the data which we just were working in Excel, I can show you how to find out the correlation and regression equation. If you want to find out the correlation, simply type here correlation, then intercept, then slope. Now on this cell, if you want to find out the correlation between age and blood pressure, type is equal to CORREL, Correl. When you double click here, small bracket will automatically appear array 1. So select this variable, then put comma and select the second variable, close the bracket, press enter. So you will find out the value of R. So as this value is positive and 0.75, so you can conclude that on the basis of this correlation, age and blood pressure are strongly positively correlated with each other. Now to find out the regression equation, we need to find the value of the intercept and then we need to find out the value of slope. To find out the value of intercept in this cell, select this cell, type is equal to, and then type the intercept, select the small bracket. Formula automatically is telling you that select known y's. So select this y variable, put comma, and now next select this independent variable, close the bracket, press enter. So this is the intercept, which is similar to what we found on the scatter diagram by adding the trend line just few minutes before. Now if you want to find out the slope, is equal to SLOPE, slope plus small bracket, select the y variable, press comma, then select the x variable, close the bracket, and then you will see here that 0.625 is the uh, slope or coefficient. So we will interpret it that, as we know that slope is a value of dependent variable when independent, slope is change in dependent variable when independent variable increases by 1 unit. So here we shall interpret it that blood pressure will increase by 0.625 points if age increases by 1 year. Now we have the regression equation, so we can type here that predict